Thanks, Sally. Hi, everybody. Good morning, good afternoon, good evening, wherever you are. We're going to take you to the journey of evaluating NoSQL databases, evaluating their architecture and performance. And first of all, let me share with you a story. Why am I here? Many tools and many databases that are, you probably don't know, but there are more than 120 databases in NoSQL, NewSQL category alone, with maybe a dozen being quite popular. It's still hard to figure out which one to use for what kind of workloads and what kind of setting. And because of most of these are commercial products, and that presents a challenge where many products, of course, they try to convey very clearly what they're good for, right? But that leaves little to no space for the messaging what they're not good for. So, and because of there are so many people try to benchmark them, the problems with benchmarks is that it's very hard to have something benchmarked and then see how it applies to you, because again, we're dealing with the same problem. Very many workloads, and your workload is likely to be very different from workload of someone else, and a combination of workloads of organization A is likely to be different from combination of workloads of organization B, and so on. So as a result, what we're witnessing is that the storm of shadow IT, meaning applied to databases, meaning that within organizations, different development groups pick the right tool for the job, they go on, and here we have a database being used in an organization for this project. And then another group says, oh, we like this, Redis is really great for that, let's use it's here, and we have Redis now. And then another group says, oh, we want Couchbase, this is a session data, we saw a case study, let's use that. And then another group says, oh, we want to store this, let's use Cassandra, and then so on and so forth. And an IT organization of a large company ends up with like a bunch of different development groups using dozens of different products. So that presents a problem where quite a lot of these products are quite good. There is nothing wrong with them, but for the IT organization that's trying to make everything work as a service and provide the security and unify it all, it presents a challenge. How do you support so many different products, right? And here are some of the example of products that might be strong containers for different categories. So it's totally not feasible to think that an IT organization can provide all of them as a service, right? So because of that, what we're dealing with is that IT teams cannot provide service level agreements for those dozens of options, and therefore they cannot be really helpful to their business units and all of this developer organization. So if they can support only one or two products per category as a service, one, let's say, best of breed document, best of breed column, graph, and relational, that makes sense. That, well, that's feasible for large organizations to provide them as a service, either from the inside or with a third party partner, and because of we already have 4, 5, 6 times more products used, we need to consolidate. So the typical goal of the problem, the typical challenge that we see in large organizations is that they want to have a database as a service, and again, this is from the IT department kind of perspective, right? They want to be helpful. They want to provide a quality service that users can rely on, that is easy to use, and at the same time they cannot do it all. So how do we pick a product, right? that's the journey I'm going to take you today with essentially 4 parts. Part 0 is explaining where is this all coming from. Why do I think is the right message? Why do I think is the right framework to evaluate products? Who am I, right, to tell you? So I'll share where is it all coming from, example of companies and use cases and problems they're trying to solve. Then I will go on and start with presenting you with the framework, with this tool set that you can take and use on your own. First of all, we're going to look at how you look at the architecture and capabilities in a manner where you can deal with dozens of different products in several categories. How to put it all in one page to deal with it. Second, I will take you through an example of the approach for evaluating performance, and the templates and the benchmarking tools I'm going to talk about are from real-life benchmarks that we have done for large and small organizations when it takes to select a database. Right? And finally, I will show you the examples of those very benchmarks and what kind of results you can produce with that framework should you decide to take on it on your own and do this process within your own organization. And then Shane will join us with a perspective, with a Couchbase perspective on this framework and how is their product stands out and what are the key elements of the architecture and the performance why Couchbase may be a good choice or why Couchbase may not be a good choice for a certain type of So let's get started. By the way, if you have any questions, I hope that we have ability to see the questions asked. I will get a notification. I'll address them as I get them. So feel free to ask and interrupt at any moment to make it more interactive for you. Well, the Altoros is a professional services company. We're not selling product, so it means that I don't have any product to sell to you, and I don't believe is that the services companies could be really good resellers because we never sold products. We had a lot of opportunities to do that, to become a reseller. But what makes it valuable for the end customer is that having a network of people like us that they can rely on for unbiased decision, where the interest of the customer is the ultimate goal and ultimate turf that we protect. Right? That should we should see more of that in our industry. I hope it will change for the better. So the work that we do for those customers, we do 2 things. We bring the software factories. Think of like assembly line or the tool belt for making applications based on the Cloud Foundry and the solutions offered by the members of the Cloud Foundry ecosystem, about 35 companies ranging from HP, EMC to the small ones like Docker. And to make them work, we really have to bring data lakes, those pools of data that needs to become available to the applications. And throughout this work, we help companies implement database as a service, deploy and operate certain types of data stores, and make them usable within the organization. Here's an example of a company that's using technologies like this for solving the business problem and essentially reinventing the business. They've been in the business of licensing music and helping musicians get famous and operate all of the entire life cycle of that business. Now everyone knows no one buys CDs, so they have to figure out how they evolve, how they should evolve to survive. And with the help of the software factories and the data lakes, they transform themselves with the new types of startups within the organization that develop new business models and experiment. Another example is a medical device and liquid drug company that aims to save lives currently lost every day because of the wrong dosage, wrong drug, sometimes even wrong patient. And that presents a data problem is to make a decision and send alerts like, oh, this patient now is getting an overdose or something wrong with the pump. You have to aggregate a lot of data from hundreds of thousands of devices, and to make that decision effectively and address all of the rest of the business requirements when it comes to security and deployment models as a service within a hospital. Some hospitals cannot send that data outside of the hospital or their country. Some hospitals don't have reliable internet connection. That presents technical challenges, a number of them. Another example of a company that's using these technologies, NoSQL technologies, to transform their business or build the entire new business model is a electronic medical record company that already has a bunch of data, and they're trying to now make it usable beyond the data access by the patients and their doctors, but by the entire ecosystem of organizations, companies, pharmaceutical companies that may want to obtain an anonymized sets of data. So these are some examples of companies that we helped, and a dozen of others that were leading to this framework. And finally, we had some time to put this all together in one picture and give it to you for your own use. Now, let's look at how we evaluate how companies, especially in this situation of how do we make database as a service available to our entire organization, how do we pick the 1 or 2 products for each category that we will focus on and provide the SLAs and deliver as a service, so that anyone who wants a certain type of database, let's say document column value, they could take and start using it in minutes. So to pick those products, first let's realize that this entire process and framework is not something that you do in a napkin in 15 minutes, and not even in a couple of days. One of the challenges of making this happen is not just about selecting and benchmarking. It's also about communicating with your teams about the workloads that they're currently running in order to meet their needs, and have an agreement from their side that yes, they may agree to switch to that database as a service product, even if they currently use another database technology, because it will be shared and the company will benefit from joint pooling of resources, right? And to make that peace and make that conversation, that's where a lot of time is going. Well, first of all, it always starts with focus and drill down on the workloads. What are the workloads? And this is an example of real-life workloads from an organization. They're in the shoe business, and they have a lot of different businesses, from old ones selling their products to new ones. The wearable devices generate terabytes of data every day, and like what do they do? when it comes to combining the company strategy and their data strategy and database as a service and all this shadow IT with dozens of different products used in the development team. So let's just pull all the workloads together and drill down more than what I showed you here. You can, for each workload like that, you can have what's the volume, what are the types of data, examples of records, and all other requirements. Then second step, we'll look at what do we want to achieve with this ultimate goal. Database as a service might mean very different things for different organizations, right? So in this particular example, the company wanted to have multiple data centers with replication between different regions so that, well, they achieve some other benefits, high availability, lower cost of doing all this like backups and disaster recovery things, and including bringing data closer to their users worldwide, and users meaning the apps and the development teams. The third step is to do just a paper pencil sort of selection where analysis is done on all of the different vendors, all of the products in this particular category against these criteria that you have picked in the previous step. It's of course it's hard to very objectively measure them on all of these criteria, yet if you have the weight on decision and you have a peer review, a couple of folks looking at it at least, overall it produces good enough measure that is quantified, and combined with this approach becomes way more objective than just, oh, this can do this so well and this product cannot do this so well, so let's pick it because of that. So every person has different needs, including IT has different needs, information security has another, operations another, developer and yet another one. And so here's an example of this template, what you come up as a result. Let's say in the particular category you have 3 finalists, right, that scored 199, 194, and 171. Your numbers might be totally different. It's again case specific. That's why we call it a framework, because you can apply it on your own. Second part, we evaluate the performance, and to evaluate the performance, we set the goals very clearly. With this framework and those examples of benchmarks that you're going to see, the goals we had is that it had to be reproducible, meaning that you could replicate it in your own data center in AWS, on VMs, just take it, run it. It has to be reproducible, and it has to be realistic with the numbers, with the meaningful numbers of, I would say, medium-sized workload. Then you set the benchmarking scenario, and you look at, we're looking at interactive web applications, Internet of Things, machine-to-machine data. It all will be different for you. Might be very similar, but we don't know that. And here's the key things what we are measuring. We are measuring latency and throughput to understand, are we going to scale well if we're going to serve a lot of different development groups, right? And how will this scale affect the performance, meaning the latency, not just like average, but at the extreme, we'll look at the extreme case. That's why 95th and 99th percentile come in. Here's an example of the data sets that you may want to have within a benchmark. These are the 2 sample ones that we used in the recent benchmark. And for the automation part of it, we highly recommend Yahoo Cloud Service Cloud Serving Benchmark, which is we help to popularize as a standard benchmark for comparing performance of NoSQL, NewSQL databases. It's open source. Download it, use it. There are a bunch of connectors. some database products, important one, what I want you to know, some products have different connectors, different implementations, kind of drivers, right? So there are some people that say, well, this driver is better or not. That will be up to you which one to use. Ask me for a specific recommendation if you have a specific workload. I may help you with that. And YCSB works very simple. There is a client node and there is the database cluster node. And the client node loads the cluster and then captures the responses. So we have, this is an example, one client node loads 4 database nodes pooled in the cluster. For some of the connectors that we have developed, looked at the fork of YCSB that we maintain at Altoros on GitHub. Examples of the benchmarks. This is the final part. I'll show you some, quickly browse through those few charts that we have generated during the last benchmark that we ran with the workloads that, with the data sets that you've seen a few slides before. So you can get an idea what kind of results you want to aim for to get out of this benchmark in order to then take those results and bring to all of these development groups and ask what they think about it, because they will say, oh yeah, but our workload is different, and here you go. You just hit, well, this is where the rubber hits the road. You bring it to their attention while you're doing it so that you can have a second and third loops of feedback to find out, oh, they think that the workloads are not correct. Well, why didn't we define them properly in the first place, right? So ideal goal is to make a change in the organization where many workloads will be consolidated within the database as a service provided by the IT organization. And while you're doing this benchmark, and while you're doing the steps before, it's critical for you to constantly talk to at least a few groups who you want to convert into believers that, yes, these workloads are reasonable, they're exactly what we have now, and yes, at least for the new applications, we will be totally fine using the database as a service if they provide a good performance and address all the other requirements that you might have. So the requirements have to be in your template, in your spreadsheet where you pick the finalists for the real world benchmark. So here's an example of the cluster that we have used. You can do it with AWS, you can do it on bare metal, it's totally up to you. These were the bare metal servers, some of the benchmarks before we've done on AWS. There are pros and cons for each approach. Let's look at the data sets again. Here's we have the data set 1 with 50 million and data set 2 with 3 million, which don't fit and fit the memory respectively. And we have the number of workloads. YCSB allows you to predefine X number of workloads. You can use the standard ones, you can create your own. That's where you link the workloads that, let's say, an inventory search query, right? Do we have a particular item in our inventory and how many? So that query represents, that workload represents one of the workloads that you design YCSB workload with this, and it becomes, let's say, workload C, for example, right? And that's pretty much how you link the workloads with the YCSB and the infrastructure, and then you run the client and start loading the clusters of databases that you configure, typically one at a time, with the same set of workloads. So this is an example of this workload B, where we have approximately balanced read updates and a little bit of inserts and deletes. This is how you can see what the products how they perform for that particular workload on that particular cluster. How you configure the cluster is also up to you. There is a way to optimize it. Every product has a bunch of different knobs that you can turn. Ideally, you want to make it so that you don't put any product in a disadvantage, right? And you can consult with the vendors for those particular products, so they could help you. You can just send them an email, say, hey, this is the workload, this is the YCSB settings. What's the settings for the product that you would recommend, right? For our customer, for example, we did all this work at one point and kind of played the role of the communicator and helped them reduce the number of people they need to talk to while this benchmark is performed. They wanted to focus on talking to their development team, so they could make that piece that is required to make the database as a service initiative a success. So here's an example of another workload. So you pretty much generate those chars as a result of the putting YCSB on a client, running it against of your cluster. Some outcomes, some conclusions that were made from this particular benchmark is that pretty much it's clear why we are here with Couchbase is that they performed extremely well with quite a lot of workloads within this benchmark, and that perhaps is the strength of the Couchbase product right here in those workloads and their characteristics. So you can use those examples as something that you may want to replicate, or you may just trust it if you are at that point and say, yeah, we like that those results we're going to benchmark using the same framework but other products, because it takes a lot of time to configure, to benchmark, and the amount of servers some companies spend upwards $100,000 per benchmark just in infrastructure costs alone. So it's not very inexpensive effort for some, but some companies have a huge value to be derived from this initiative of making database as a service. So they treat it as an investment that will be monetized and returned pretty quickly, because the sheer scale of their operation is so vast that they probably will get that investment return in like 6 months as soon as they get the usage. And the lessons that we learned is that absolutely you need to run the benchmarks, especially if you want to make peace with other members of the teams and make a change in the organization to truly optimize the way that your teams are using the products, and whether you're going to be using those products and providing them on your own from your own data centers, AWS, anywhere, or even if you are consuming those products as a service managed by a third party, it still makes sense to look at what the underlying performance of those workloads, because you don't want to consume the database as a service very widely in your organization if that product is inherently very expensive to scale, right, and operate. So if you would like to get more details and want to take action and see how it's structured in a step-by-step manner, feel free to download this report that we have put together with around that particular benchmark charts from which you have seen. The link is here, and some of you, I got one question last time I presented a talk about the benchmarking at NoSQL Now conference in San Jose this August. How about Hadoop? Other benchmarks for Hadoop, do they exist? Like we also have Hadoop initiative, right? Yes, they do exist. The good news is that The Hadoop by default comes with a benchmarking suite called TerraSuite. It's a TerraGen, TerraSort, a bunch of standard tests for to benchmark your cluster, which you just deployed. It comes with all distributions by default with Apache, Cloudera, Hortonworks, Mapr, PLHD. Everyone has them, so it's easy to get to start benchmarking Hadoop. And if you want to get an example of the Hadoop benchmarks, how they fare, we produced the Hadoop benchmark as well. And pretty much that concludes my part, and I would welcome your questions, if any, and pass the baton to Shane.
Thank you, Renat. As you may have been able to see from Renat's slides, in particular those with the template on it, the comparison report is outstanding. I would really encourage everybody to take a look at it, whether you find it on Altoros.com or Couchbase.com. We both have it hosted. It is 50+ pages of technical information. It's looking at these three databases in multiple dimensions with multiple criteria, not just from a very high level, but actually getting pretty deep into the architecture of these databases. So what I wanted to do for the last few minutes here, before we open this up to get some questions, is to highlight some of the major ones that are in this report. So I want to talk about a few that I'm particularly passionate about and share the details of those. But please feel free to look at the report to get the rest. In particular, I think the two big ones are the topology. There is a lot to be gleaned from a database when you look at the topology of it. And the internal architecture is equally important. We can say this about any application, whether it's a web application, a mobile application, an enterprise application. The same is true for your database. You should know and understand the internal architecture. And then we'll just end it with a few notes on how Couchbase is improving its own architecture, both with our 3.0 release, which just came out, as well as a preview of what you can see in our next release. So we'll get straight into the topology. And I think what's interesting, we'll start with MongoDB, is the complexity of it, and taking a look at what's going on. In this case, we have a sharded environment. So you have clients. Those clients have to talk to routers. Those routers have to work with config servers. And then once they understand where to route the request, they'll route it to one of the primary nodes. By default, replicas are essentially passive. They're not really participating in the conversation. They don't handle reads or writes. Their function at this point in time is merely availability and backup, so that if one of those primaries were to fail, another node, which isn't on here, the arbiter, would be responsible for selecting one of the replicas to promote it to be a primary. So there's quite a bit of action going on here. And I could talk about, there's different ways to configure this, of course. I mean, we're looking at a default configuration. Certainly supports the opportunity to read from replicas, though the data might be inconsistent. If you want to ensure that the data is consistent between the primary and the replicas, then you would have to make those calls synchronous, which means they're going to slow down a little bit. But point being, this database has multiple components, from routers to config servers to arbiters to concepts like shards and replica sets. Quite a bit going on. On the other hand, if we look at Couchbase Server and Cassandra, conceptually very similar. There's just lots of primary nodes. Every node is essentially a primary. So that one client will talk to whichever node happens to have the data that it needs. There's no intermediary. There's nothing else really going on. And as you scale out, you just continue to add more nodes. So that is one that I tend to want to talk about a lot with people, is understanding the topology when it's fully deployed and understanding what that impact is. And it impacts a lot. We'll go through each of these. This is just a sample of 6 different areas where, if you're looking at the comparison report, you will see elements of the topology surfaced in these different criteria because ultimately you can kind of track it back to the topology. So if we're looking at the installation, the first question I'm asking is how much do you have to install? Do you just install the same thing multiple times, or are there different things you have to install? Do they have to go in certain places? How is it going to affect that? We could look at the configuration. Conceptually, not too dissimilar to the installation. Do you just configure a database, and as you add more nodes, you just apply that configuration? Or do you have different types of configuration? If you make an update, does it update all of them at once, or do you have to update different things? It's gonna have an impact on that. And then consistency, which I was just mentioning. When we're looking at MongoDB, it's going to be consistent by default because you're going to read and write to those primary nodes. But if you wanted to read from replicas, you're either going to sacrifice consistency or you're going to sacrifice performance. The choice is yours. If you look at Cassandra, being really well engineered for availability, the data may or may not be consistent. By default, it's just going to get you the data from a random node that has it. Should you want it to be consistent, then you'd have to start using things like quorums, where you have to get a majority of the data owners to agree on what the right data is to return to you or to accept. With Couchbase Server, all of our nodes are essentially a primary for some part of data, and then they're also a secondary for some other node's data. So we're consistent by default because we do read and write to primaries, but conceptually the difference between us and Mongo is that all of our nodes are primaries. They serve as both primaries and replicas at the same time. And then fault tolerance. What does it mean if any particular node fails? If you're looking at Couchbase and Cassandra, both of these types of NoSQL databases can allow any arbitrary nodes to fail and keep functioning. On the other hand, if we're looking at MongoDB, if we lose the config servers or we lose the routers or arbiters are unable to elect a new leader, any of those components can cause a pretty catastrophic failure on the database to continue to function the way it always has. And you put 10 nodes across those servers, are you using 100% of the resources available to you? When we look at Cassandra and Couchbase, they're using 100% of those resources because all of those nodes are active. They're all servicing read and write requests. If you're looking at MongoDB, only about a third of those nodes could be accessing read and write requests. You could certainly double, triple, begin to start installing multiple nodes on those physical servers to try to get more of that resource usage, but you're also doubling and tripling your cost as well as you buy additional licenses. And then scalability. What does it mean to scale out? Is it as easy as just adding another node and calling it a day? Add 2 nodes, add 3 nodes? You're going to see this. Or is it, I have to put some thought into it because I can't just add one more node to scale out. I might have to add an entire replica set or add a node to multiple replica sets. So what's the impact of the topology on both the beginning from installation and configuration to kind of maintained, over the long term, dealing with the administration and performance expectations, to realizing a great deal of success and having to scale out, quite possibly very quickly? What are the impacts of that on you? And I can tell you that a lot of that stems from the topology and understanding the impact it has on these areas. The other area is the architecture. And I'm kind of going over high-level parts here. You can find more in the report. MongoDB is very well known for using memory map files. Essentially, they're writing to files, but they're doing it through memory. So they have a file with data, map that file into memory, and we can read and write from it. And conceptually, it should work well. And it does if those files fit into memory. Once you have a great deal of data and they're unable to fit in memory, we start having issues. If you've mapped half of the file and a user needs data that's in the other half, then MongoDB has to swap them, right? Or rely on the OS to swap it and say, okay, take this half of the file, eject it from memory, load the new half in, and find the data we're looking for. The other aspect to consider that is its update in place, which can kind of be difficult over the long term. If you have a very tightly mapped file and you want to update an object but it's bigger than what it used to be, you can't update it in the same place. There's no room. So you have to put it at the end of the file and you leave a gap in the middle. And over time you can get many of those gaps throughout your file. Then of course it has to be condensed to be small again. From a durability perspective, it's asynchronous. Most databases are generally asynchronous, only in so much that, to be durable, we're talking about writing to files. Most operating systems, when you write to a file, they don't immediately write it to disk, right? There's a certain function called fsync, which will tell the operating system, please put it on disk right now. But that call is generally performed every once in a while, regardless of the database. Another key thing to point out is MongoDB relies on database-wide locking. So any one given node, if you have a database where you're putting all your data in it, there's one lock, and it's a shared lock. So if you have many users writing something, they have to take turns getting those writes in. Something I know that MongoDB is going to resolve in their next release, though. If you look at Cassandra, they use a log-structured merge tree, an LSM tree. We see this in other databases as well, like LevelDB and RocksDB. They do use the mem table well to kind of help with write latency. So writes are going into memory first, and they're going in that mem table. As part of that process, they can be written to a commit log. And then eventually, every once in a while, that whole mem table is drained. It's flushed to disk in the form of an SS table. From a durability perspective, it can be asynchronous, much like other databases, but they do have a concept of a synchronous batch, where if a whole bunch of writes come in, it can hold all of those writes until some time interval, 10 milliseconds, 100 milliseconds, then call fsync to write all of that data to disk. So in that regard, it is synchronous and it is durable, but you pay a performance penalty. The latency is going to go up because you have to wait 10, 20, 30, 40, however many milliseconds you've set up until that batch is full, and then it's flushed down to disk. And in much improvement, they do row locking. Right, so very good from a write concurrency perspective. Many users can do many writes all at the same time, which is a fantastic thing. And then we get to Couchbase Server. We use something we call copy on write B-tree. It's append only. This makes a lot of sense, especially when you consider that things like solid-state drives are append only as well. That's how they work. Much like Cassandra, the data can be asynchronous or synchronous. If it's asynchronous, it will be very quick, very low latency, very high throughput. Or if you're very, very concerned about durability, it can be synchronous, in which case it's going to be a little bit higher latency, it's going to be a little bit slower, but you can rest assured that your data's been written to disk when you get the response back. Another big difference here is we have an integrated managed object cache. So whereas Mongo was relying on the operating system to map some stuff into the page cache, and Cassandra is using a mem table to help kind of batch the writes, we have an actual object cache. This would be very similar to MongoDB with Redis, or MySQL with coherence. Anything, if you've ever been in a situation where you have both a database and a cache, put those two together, and that's what we have in Couchbase Server. So we're getting all the benefits of caching plus all the benefits of a database. And then much like Cassandra, where they have row locking, we have document locking. So again, we can do many, many writes concurrently for many, many users. A couple improvements in Couchbase Server 3.0, and I'll just give you a highlight of them, is the database change protocol and tunable memory. The real importance behind the database change protocol is we have what we would refer to as a memory-centric architecture. Part of what DCP does is in any distributed system, data has to be moved around when it's scaled and when it's operational, whether that means indexing new data, replicating it to other nodes for availability, replicating it to other data centers for disaster recovery. And that's what database change protocol was designed to do, was to leverage memory and the disk where necessary to stream those changes to different components and different nodes. Tunable memory was an important change as well. On one hand, you can choose to keep all the metadata in memory, and this allows you to know where on the disk that data is. So you can retrieve it from disk very quickly because you know precisely where it is. On the other hand, it can be a challenge if you have a great deal of data and not enough memory to store all of the locations. And so enter tunable memory, which allows us to eject that metadata and just keep, the hot data. What's mostly important to us right now. We're going to keep that in memory. For everything else, we know how to find it on disk, with or without the metadata. So short story on tunable memory, you can store much more data much more efficiently. And then Couchbase Server 3.x, what we look for in the future. One of them is NoSQL. That's our query language. It's a superset of SQL. It's the type of SQL that you've worked with all your life. Select from, where, join, those types of statements, plus additional statements and functions because it's a document database. And then ForceDB, which we've been talking about lately as well, which is our new storage engine that we've been working on. It's currently in beta. It's been optimized for solid-state drives, and we expect to get a great deal of performance improvements, as well as new options for durability when that comes out. One last thing I wanted to remind everyone here, especially when you look at, DCP and tunable memory, NoSQL, as well as ForceDB. We just recently held our annual user conference in October, and we have all of the sessions, the videos, and the presentations online. It's couchbase.com/connect. If you click on sessions and then you click on architecture, you'll see that we have sessions for all of these things. You can watch the deep dive in DCP, understand more about tunable memory. You can get an insight on our new storage engine. And there's sessions on NoSQL as well. So I would encourage everybody to take a look at that. For ForceDB, that's on GitHub, like all of our projects. It's github.com/couchbaselabs/ForceDB. And if you want to get your hands on with NoSQL, you can go to n1ql.couchbase.com, click on the language tutorial, and you can take a look at some of those SQL queries that are going to look very familiar to you and how you can use those with Couchbase Server. So that's all I had. Thank you very much. Thank you, Renat, and thank you, Altoros. The technical report is fantastic, and I encourage everybody to take a look.
Great. Thank you, Shane, and thank you, Renat. Looks like we have about a little under 10 minutes left for questions, so I remind everyone to use that questions tab in your GoToWebinar control panel to ask a question, and we'll do our best to get to everyone. So with that, it looks like we have a few already here. The first one is from Vineet, and I think it's for you, Shane. When will NoSQL be released to use in a production environment?
NoSQL is currently in developer preview right now. You can expect it fairly soon to enter beta, and then I would start looking towards early next year to see that rolled into a next major release of Couchbase Server. So we still have a little bit of work to go. We're still going through the development process, but you can use it right now. The SDKs have all been updated to allow people to start playing with NoSQL and using it on their instances as of today.
Great. The next question, Renat, I think is for you, and it's from Daniel. We'll see if you can answer it. We might need more context, but from Daniel, Renat, any thoughts about Azure? Renat, are you there?
Well, I can jump in on that one really quick. For
yes,
Renat.
guys, I'm here. I just was on mute.
There he is. Okay, so
yes.
I'm just going to make a quick statement, Renat, and then I'll give that one back to you. Regarding Azure, we just worked with Microsoft to get Couchbase Server up on Azure.
Wow,
so
awesome.
It's now available to use on Microsoft Azure if you want.
Yeah, that's really great. If some of the attendees are interested in doing benchmark on Azure, I would be up for that. Ping me. I would love to work on this and pull the resources. That's really great news.
Great. Next question from Charlie. How does sharding work with RAID 0?
Well, I wouldn't be answering that one, I guess.
I could touch on it just a little bit. Conceptually, they're similar. So we shard or partition databases to distribute the data amongst many resources so they can be done concurrently. If we're writing 10 different shopping carts, they could all be written to 10 different servers, which is great. When we start doing RAID, depending on the configuration, we just start to do that at a hardware level, where if we have a bunch of data to write, instead of writing it sequentially to one disk, we could potentially write small pieces of it at the same time to multiple disks. And that's where we're getting for with RAID. But as I said, it depends on your RAID configuration.
Great, thanks, Shane. Next question is from George, and I think it might be for both of you, so maybe we can both touch on it. So the question is, it seems that Couchbase and Cassandra are similar in many ways, but what's the distinct difference between the two, and what are the typical use cases that fit for each database? So Renat, maybe do you want to start?
Yeah, well, I would say that Couchbase has the document capabilities. So what we've seen is that Couchbase, in some of the evaluation, placed in two categories of products in that competition, in that Olympics, if you will. So that I would say the key difference, and of course the others are. They might relate to specifics, how you plan to use it. When it comes to like advanced features like secondary views and all of that. So I wouldn't get into that depth, but the key difference is that I think Couchbase might be applicable in two categories instead of one.
I think that's pretty spot on. I think Couchbase Server is a great key value store, and it's a great document database, whereas on the other side, we have Cassandra in kind of the wide column family. So the data models are different, and I think that's going to be very, in some regards, it can be application specific. It's going to be up to you as a developer to decide what data model you're comfortable with and what you think is going to work well for you. And I think Renat was also right that some of the differences start to appear in some of the features as we start to move on. So if we talk about cross-data center replication, the way Couchbase and Cassandra go about it is two very different ways. The very short answer is Cassandra treats multiple clusters in multiple data centers as being a single supercluster. So conceptually, if you have multiple data centers, you still think of it as being one cluster, one database. Whereas Couchbase Server treats each data center as kind of an independent cluster. And so we start to be able to do more types of topologies where we can replicate one to many, many to many, many to one, hybrid cloud, kind of gives you different options, but both great databases.
Great, thank you both. Next question from Keith for Shane. What is a good reference in addition to your documentation on how to design your documents to replace complex relational database management design?
That's a pretty good question. On our website, I believe we have a relational to NoSQL white paper, which could be of some value. And Ellie, you might know better than I believe in the webinars, we have a 101 to 105 series. And one of those focuses precisely on data modeling with some concepts on carrying over from a relational world. So I would say check out the webinars and the presentations on Couchbase. There's going to be some good stuff in there on how to get started.
Great. Next question. How does Couchbase performance compare with Hortonworks Hadoop?
Well, our comment here is that there is a phrase, there are different horses for different courses, and well, also you can apply MapReduce approaches with NoSQL database. I would think my question would be, the counter question would be, is your problem really of a scale and type that that cannot be solved with the database products in the NoSQL, NewSQL category? If I look at the cases that we've seen, there are a bunch of use cases where people start using Hadoop, but I think they shouldn't because the case is simply not there. And many of these problems that people use Hadoop for can be solved with NoSQL database at lesser expense and solve some other problems along the way. But other than that, I would pass to Shane as far as the differences.
I mean, I think I'm thinking the same thing you are. We have many customers that use Hadoop and Couchbase together. I'm sure that if you were to look at a broader group of enterprises out there, they're using some combination of relational technology, NoSQL databases, and Hadoop. So I don't think of it as an either or for myself. I usually think of it as a 1+1 deal. Use them both, and kind of going one step farther in that, the database is great for your operational workload. So the apps that you're writing, those apps should be reading and writing to a database. If you're doing analytics, whether it's near real time, machine learning, visualization, that's an area where Hadoop is going to have a profound impact. The only other thing I would add in there is certainly you have HBase, which is kind of Hadoop's NoSQL database, column store. My personal opinion on that matter is that HBase is really a way for Hadoop to check the NoSQL box, but not often considered a mature, fully featured database. So it's there, but I would agree with Renat. I think depending on your app, look at a NoSQL database first, or whatever database of choice you're looking at.